Notes, 3.4 day 1, we are graphing linear equations. That means we are graphing lines. There are a few different ways to graph lines. Today we're going to graph in what is called standard form. So if a graph or if a linear equation is in standard form, it is written as ax plus by equals c. A, B, and C are just numbers. Okay, A, B, and C are just numbers, and this is your general form that this is in. AX plus BY equals C. First thing we're going to look at is just basic horizontal and vertical lines. Horizontal lines, these are our lines that go from left to right. Vertical lines go up and down, okay? When you graph, or if you have to write the equation for anything with a horizontal line, there's a few things to look for. So when we graph, we have an X and a Y axis. Our X axis is from left to right. Our Y axis is up and down. If you graph a horizontal line, what happens is, wouldn't a horizontal line go through a vertical line, right? So what happens is a horizontal line goes through your y-axis because it's vertical. Okay, so what ends up happening is when you write an equation for a horizontal line, it is a y equals equation. So what this will look like is y equals b, and then b is just a number, okay? So if you graph a horizontal line, it's y equals some number. Now, what is that number? Well, that number is where your graph crosses the y-axis, because it's the only number it goes through. We'll see that in a second. Okay, so if you have a line like y equals b, then it is a horizontal line. Oh, that stopped working. You guys see that? Well, that's supposed to say horizontal. It won't let me write the word horizontal. You see that? It like had it's like possessed. It's a little bit better underneath, but it's still not really cooperating. But I actually have terrible handwriting. Okay, so this is what your horizontal line will look like. It'll be y equals a number. Okay, your vertical line, that one is in the form of x equals a number. So the graph of x equals a, where a is just a number, is a vertical line. Okay, that goes through the point A. Now, if you have a vertical line, it's x equals because it goes through the x-axis. It's the only number it goes through. Okay, and this would be what we call an x-intercept. Because that's where it intercepts, like an intersection, like in a road, right? It's where two roads cross. So in math, you can have that, but with like a coordinate point. Sorry? No roundabouts. Sorry. All right, so this is easier to see if we just try it out. So for the first one, we are going to graph the line y equals 0. Or y equals 4, sorry. I was distracted because I was watching Hayden on his phone. So y equals 4. Okay, so here's the easiest way to do this. You're like, I don't know if it's supposed to be horizontal or vertical. I don't know anything that's happening right now. So if you have y equals 4, where's your y-axis? Does the y-axis go left to right or up and down? Up and down. If you look at the up and down axis, do you see the number 4 on it? Yeah, what you're going to do is put a dot at 4. Okay, dot at 4. Now, what you need to do is draw a line through it. Now, the question is, should that line be horizontal or vertical? Well, question for you. If you draw a vertical line through this, wouldn't a line going through 4 look the same as the line going through -2, look the same as the line going through -7? Aren't all your lines supposed to look different? Yeah, so would it make sense to draw a vertical line through there? Isn't there already a vertical line there? Yeah, you don't want to draw it over the vertical line that's already there. So instead, we're going to draw a horizontal line. So draw a horizontal line, and on your line, I need you to put arrows on either side. Yes, arrows. Okay. I wonder if I can make that thinner. Okay, guys, calm down. All right, so now you'll notice these two blanks. We have the x-intercept and the y-intercept. Now the x-intercept is down here. Does your graph ever touch this line? No. So what that means then is there is no x-intercept. We're going to simply say none. The other way you can tell that is if you look at your equation, do you see an x anywhere in it? No, there is no x. There's no x anywhere. Say none. Now y-intercept though, take a look. Where does it go through y? At what number, Asia? Asia, you had your hand up? 4. Okay, so now the question is, how do you write that? You do not just put a 4 on the line, because an intercept is a point, and points are written as x comma y. Now the question is, what's what? Well, didn't we already agree there's no x? Yeah, there's no x. There's no x anywhere here, so x is just going to be 0, comma, and then y would be where it goes through your y-axis, which was the number 4. So glad you're awake today, Jaden. All right, so number 2. All right, number 2, we got x equals -2. So this one, there's only an x, right? X equals 2. If you take a look at your x-axis, do you guys see the number 2 on it? No, yeah, -2. Put a big dot at -2 on your x-axis, because that's what it says. X equals -2, so put a dot at -2. Then, if I need to draw a line through this, should I draw a vertical or a horizontal line? Vertical, because if I draw a horizontal line, isn't there already a line there? Yes, Jaden. You may sharpen your pencil, yes. So draw a vertical line going through that. Okay, use your ruler, make it nice, put arrows at the end of it. I do take off points if you don't put arrows. Lines don't end. All right, now intercepts. Do you guys think there's going to be an x-intercept on this one? Nope. Why yes, Asia? Yeah, isn't x the only number you have here? Yeah, it goes through x at what number? At -2. So remember, a point is x comma y. So if it goes through here, what's your x value there? -2, because that's what your equation was. And then do we have any y's at all? Nope, so y would just be 0. And then, yeah, take a look at your y-intercept. Does it ever go through it? Is there any y anywhere in this problem? Nope, so we would just say none. All right, let's continue. Questions about that yet? We have this one copied? Okay. All right, moving on to number 3. We got y equals -2.5. Okay, so y equals, go to your y-axis and put a dot at -2.5. Where do you think -2.5 is going to go, Jake? Well, Jake, what were you going to say? What did you say? It's actually not going to go above 2. It's going to go right below -2 because it needs to be between -2 and -3 because it's -2.5. So you need to put a dot right between -2 and -3. Okay. Now, are you going to draw a vertical or a horizontal line through this? Horizontal, so use your ruler. I would use a ruler if I could, but I cannot on my device. So I'm going to do the best job I can. I think I did pretty good. Okay. Thank you. So there is your horizontal line. So now, are we going to have an x-intercept in this one? What do we think, guys? Are we going to have an x-intercept in this one? No, it does not touch the x-axis at all. So we're going to say none. Then for the y-intercept, remember these are coordinate points, x, comma, y. Well, if x is none, are we going to have an x value here? No, so we just say 0, good. And then what would our y have to be? -2.5, exactly. Good. Huh? Okay. All right, guys, why are we interrupting? We have less time today and we just like are talking. It's driving me bananas. All right, number 4, we have x equals 5. X equals 5, so where do I want to put a dot? On which axis? The x. So on the x-axis, put a dot at 5. No. All right, so now do I put a horizontal or a vertical line? Vertical, there's already a horizontal there, so we need a vertical line. Don't forget your arrows. Now remember, intercepts are x, comma, y. So is there going to be an x-intercept for this one? What do we think? Does it go through x? Yes, so will there be an x-intercept? Yes. What would the x number be there? 5. And is there a y? No, so we just say 0. And then what do we say for the y-intercept? None. Good. People at home, any questions so far? I'm going to take the silence as we understand this so perfectly. Okay, I want you guys to try out 5 and 6, please. Look at 5. Olivia, where am I going to put my dot for number 5 if it's y equals -6? Yeah, on which axis? The y-axis. Put a dot at -6. Jaden, put the ruler down. Put a dot at -6 on the y-axis. Alex, do you think I'm going to draw a vertical or a horizontal line going through this? Yep, absolutely horizontal. Good. Jesse Campbell, is there going to be an x-intercept on this one? Jesse's not sure if he's there. So Aiden, is there going to be an x-intercept on this one? No, it does not go through x, so we would say none. And then Annalise, what'd you say for your y-intercept? It is -6, but remember we have to write it as a coordinate point. Yep, 0, -6. Good. Good. We good with that one? Fix it if you got it wrong. And then for number 6, Aaron, where are we going to put a dot? On which axis? Yep, put a dot at -4 on the x-axis. Lynn, is that going to be a vertical or a horizontal line? Vertical, good, good. That's okay, good save. Oh, except that's a really ugly line. And if you ever get it confused, you can always I'll accept up or down. And if you're I don't remember, but I know it goes up and down, we can then talk about it. That's a little better, I guess. Dallas, what'd you say for your x-intercept? Good, -4, 0. And Hayden, what'd you say for your y-intercept? None. Good. Questions, concerns? Feel pretty good about these ones? These ones are easy. All right, onward. On to the back. All right, so now this looks, I promise you that this looks a lot more complicated than it is. So there's just a few things like you have to start by explaining. So x-intercepts, using intercepts to graph equations. Now we just talked about intercepts, right? It's where it either crosses the x or the y-axis. Now the horizontal and vertical lines only have one intercept, but sometimes lines have two, like if you have like a slanted line, right? It might cross it twice. So the x-intercept, that is where the graph simply crosses the x-axis. Okay. That happens when y is 0. If you're at the x-axis, y is 0. We saw that in our coordinate points that we wrote down. And if we write an x-intercept, remember you write it as your x value, comma, 0. Right, we just did that before. We would put our x value, comma, 0. Then y-intercept is very similar. That's where the graph crosses the y-axis. If you're at the y-axis, then x is 0. And for these, we write our points as 0, comma, and then y, like 0, comma 2, 0, comma -3. We just did that on the front. Now, in these situations, these are more what our graphs are going to look like. They're going to be slanted, and they're going to cross the y-intercept once and the x-intercept once. Now, if you did the notes yesterday, it might be a big if, I haven't looked yet. You might have noticed that to make a line, how many points do you need? 2. To make a line, you need 2 points. Now, when we can, we like to graph 3. 3 is better, okay? But with these, if we can just graph 2 points, an x-intercept and a y-intercept, we can connect them, and then we'll have our line. So, to graph the intercepts, or to graph, find the intercepts and draw the line that goes through them. So you draw your 2 intercepts, you take your ruler and you connect it with a nice straight line. Here's what we do. If something is 0, doesn't that kind of mean you can ignore it in your problem? Like if you add or subtract 0, does that matter? Does that change anything? No. So what we do with this is we use what is called the cover-up method, okay? So to find the x-intercept, what we do is we cover up y. So to find x, we cover up y and solve for x to get our new point, x0. We'll see what that looks like in just a second. Then to solve for y, we would cover up x and then solve for y. And when I say you cover it up, I literally mean like you take your hand or like a Post-it note or something, and or a ruler, and you literally like cover it up. Okay, I cannot cover it up on here, so I'm going to like scribble over it. Please don't scribble over it on yours because you won't be able to like erase it, especially if you're like writing in fun or something. Okay, so, and this is a Y. It's just like glitching and not letting me write properly. There's also, do you guys remember when you did back in the day, like y equals mx plus b, and you had something called a slope? You can also find the slope of these lines by doing m equals the opposite of a over b. A is the value that's attached to x, b is the value that's attached to y. I'll show you how to do that for each of them too. Okay, so for number 1, we have 3x plus 4y equals 12. We are going to use our cover-up method here. Now let me tell you why this is a really nice one to use your cover-up method for. Look at the 3 numbers in this problem. You got a 3 and a 4 and a 12. Anyone know why those might be really nice numbers? Can anyone notice something, Jake? Huh? Yeah, doesn't 3 go into 12? Doesn't 4 go into 12? This means this is a really nice problem to do the cover-up method with. So here's what we're going to do. We're going to find our x-intercept. Now to find x, we're going to cover up y. So here's what I'd like you to do. You can use your hand, a Post-it note, a piece of paper, a ruler, whatever. And we are literally going to cover up y. Okay? No, you can just like think about it too. Okay, so if you cover up y, then what happens is we're just left with 3x equals 12, right? If you cover up y, isn't that all that you see? Okay. Can you then solve for x? What would you do? You divide both sides by 3. Okay, what is 12 divided by 3? 4. Okay, good. That's my x-intercept. How do I write that as a coordinate point, though? Yeah, you are going to graph it at 4, and when I ask you to like write it as an intercept, remember that's x, y. Your x is 4, and we covered up y, so y would be 0. Okay. Now we're going to do the exact same thing to find y. So to find y, we're going to do this again, except this time we're going to cover up x. So cover up x, and you just have 4y equals 12. So what would you then do to solve for y? Divide by 4. And what's 12 divided by 4? 3. So then your y-intercept would be 3. X was 0 because we covered it up, and then y is 3. And that's a parenthesis, not a 10. It's like glitching out again. Okay. So now do I have 2 points? Can I graph them? Can I connect them? Yes. With which part? It's probably because you were staring at your computer screen. I don't know, you were just like this for a long time. Yeah. So with this, what we did, Lynn, so to find x, we covered up y, pretend it's not there, right? And we would just have 3x equals 12. Then you just divide by 3 and we get 4. Does that kind of make sense? Okay. Then to find y, we covered up x. And you would, if you pretend that that's not there, wouldn't you have 4y equals 12? So then you just divide by 4 and you get 3. And then we just wrote them as points. Does that help a little bit? I think you're just spaced out for a second. Okay, so now let's plot those. So we're going to have a dot at 4, 0. So on your x-axis, go to 4. That's 4, 0. Corey, wake up. And then at your y-intercept, go to 3. Okay. Did we put our 2 dots? Now what do you do with your 2 dots? You connect them. So use your ruler, connect these. I don't think it's like possible to draw a straight line on this for me. But it's close enough. I'm doing the best I can on here. I'm very dependent on a ruler to draw a straight line. So, okay, so that's our general process. So we're just going to try this again, see how it works with each one, okay? So for number 2, let's go over to that one, and we're going to follow our steps. So first thing we need to do is we are going to find x by covering up what? Y. So cover up y. And what do you have if you cover up y? 2x equals 4. Good. Then what would you do to solve for x? Divide by 2. Good. Ladies and gentlemen, what is 4 divided by 2? 2. Oh, don't say that. Okay, so now x is 2. What is the appropriate way to write that as a coordinate point? Very good. 2, 0. Good. You're probably hearing the road. Yes, this is possible. We're not that far away from 49. Okay, so now let's do the next one. We are going to cover up, if we want to find y, what do we cover up? X. What should I write down if I've covered up x? I want you to be careful here. Pay attention. What exactly do I write down? No, I covered up x. Like, what's my new equation, Jake? Negative y or negative 1y equals 4. I want you guys to pay attention. See how there's a negative in front of that y? Do we just get to ignore that? No. This will be negative y or negative 1y equals 4. Now, I want to get rid of a negative 1 in the front. How do you think I do that? It's the same as like multiplying by negative 1. So to get rid of that, I divide by negative 1. Can you actually put the negative 1 in front of it if you want, if that helps you? Sure. Okay, so divide by negative 1. And what is 4 divided by negative 1? What kind of a 4? Negative 4. A negative divided by a positive would be negative 4. And then I have that y is negative 4. What's the appropriate way to write that as a point? Olivia? Very good. 0, negative 4. Good. Now we're going to plot our 2 points. Now be careful when you plot these. They're easy to plot like opposite, okay? So if you have that x-intercept is 2, 0, go to your x-axis and put a dot at 2. Go to your y-axis and put a dot at negative 4. And then connect them. Then estimate it, but I think everyone today should be on there. I tried to make sure that they would all go on there. And then put your double-sided arrow through it. Okay. How do we feel about this so far, guys? Yeah. Well, and that's why we practice it. That's why we'll like do the activity tomorrow, practice it. We'll do some of them together. It's just extra practice with graphing lines. We are doing an activity tomorrow. I know, listening is hard. Okay, so for number 3, we have x plus 4y equals negative 10. Now with this one, you might look at it and why might this one concern you with the cover-up method? Anyone notice? Well, not necessarily negative or positive. That's okay. 4 does not go into 10. Now that means we'll have a decimal. That's not the end of the world, but I'm also going to show you another way you could do this if you're like, oh, I don't like decimals. I don't want to do a decimal. Okay. It won't, well, I guess I won't show you. I'll show you for, I know we actually do that next week, but I know I'll show you anyway. Okay. So let's first do the cover up method. It's going to be a decimal, but it's a nice decimal, so it works out okay. So let's find our x-intercept. Oh yeah, this was the one that didn't fit, right? Yeah, that's okay. We'll estimate it. So with this one, oh yeah, it's because I changed my graphs. We have to cover up what to find the x-intercept? Cover up the y. So let's cover up the y. To find x, that's going to simply leave us with x equals negative 10. Is there anything extra to solve there? No? Yeah, you can. How would we write that as an x-intercept, though? Mason, you paying attention over there? You sure? Okay. Yep, negative 10, 0. Okay. Now with this one, is negative 10 going to fit? That's not ideal, okay? So I did change the graph on this, so it's not perfect, but just estimate it, okay? I won't on the test give you any that don't fit. If negative 6 is over here, we'll just estimate it a little bit to the left. We'll put it like right here, okay? So just estimate it the best that you can. All right, now let's find our y-intercept. So to find the y-intercept, what do we cover up? The x. And if you cover up the x, you're going to have 4y equals negative 10, exactly. And then what do we divide both sides by? 4. We're all allowed to use calculators in this class, so don't panic if you see something that you're like, I don't know how that divides. Negative 10 divided by 4, Aaron, what'd you get? I just see that you have a calculator. Yeah, negative 2.5. That's an okay decimal to plot, right? It's not a weird, crazy one. Okay. So if y is negative 2.5, when I write my coordinate point, if it's a y-intercept, what number do we use for x? 0. And then, see, it's like something on this side of my screen. I did not draw a 0 that big. Anyway, and then it's negative 2.5. I know, I don't know. I'll need to turn off my computer and turn it back on again later. See? I got it last year. Well, whatever, pretend like there's a 0 there. I know, I made it worse. All right, so then put a dot at negative 2.5. So that's on your y-axis. Go down to negative 2 and then another half. So that's right in between negative 2 and negative 3. And then connect it with your line. It's a 0 that my computer wouldn't let me draw. It glitched out. Okay. All right, so something else I want to show you guys, because obviously like this one didn't fit very nicely. We had a decimal, right? Now there is another strategy we can use if you get like weird numbers and you're like, oh, these are weird decimals, I don't like these. We can also find the slope using the little formula I gave you up above. It's called the slope. That's like, do you guys remember talking about rise over run? It's like that. So if we're doing something like this and you wanted to find the slope, what you do, slope is opposite, oh, sorry, 1 second. And we'll talk about this more next week, but slope is the opposite of A over B. So slope, for some reason, the little letter they picked for slope is M. Don't ask me why, I didn't make it up. And we do opposite of A over B. Now, what's A, what's B? That's like the big question. A and B are actually numbers in your equation. Oh, okay, that's fine. Okay, so A is whatever number is in front of X. So if you look at this problem, what number is in front of X? It's invisible, but what's technically there? Not a 0, because a 0 would make it disappear. What number can be invisible in front of a letter? A 1. So technically in front of this X is a 1. What's technically in front of this Y? Well, even not technically, it's literally there. What's in front of this Y? A 4. So if I want to find my slope, another way to do it is to take the opposite of A over B, which is, what's the opposite of a negative or a positive 1? A negative 1, which is what's in front of the X, and then take what's in front of the Y, and that's a 4. Sorry, I'm just introducing it so that you're not so that you'll at least have seen it once before next class. Okay, don't worry, we'll ignore that for now. I just wanted to show you. Don't know why, just felt like confusing you for a second. All right, moving on. Number 4. All right, so for number 4, this one, again, we're going to end up with a little decimal, but that's okay. What do I cover up to find X? Y. Cover up Y. What do I write down after I've covered up Y? What do I have? Negative 4x equals negative 18. Good. What do I do from there? Divide each one by negative 4. Good. What's a negative divided by a negative? a positive, and then 18 divided by 4, it's going to give us a nice decimal. It actually gives us, yeah, 4.5. Good. What's the appropriate way to write your x-intercept as a point? 4.5, comma 0. Good. All right, now let's find our y-intercept. What do we cover up to find the y-intercept? X. What do I have if I cover up x? 6y equals negative 18. Good. What do I divide by? 6. Good. Divide by 6. Negative 3. Sound like Pinocchio. All right, divide by negative 3. Good. Or don't divide by negative 3. Divide by 6 and you get negative 3. Because a negative divided by a positive is a negative. How do I write this as a coordinate point? 0, negative 3. Good. Now let's put our 2 points. How would I plot 4.5? In between the 4 and the 5. So go to your x-axis, put a dot between 4 and 5. On your y-axis, put a dot at negative 3, and then connect them. Oh, that one was a pretty good line. Look at me go. Thank you. All right. I think we have time for one more, and then we'll call it a day. Yes, but it's not due till Wednesday. Don't worry. Yep. Or Thursday. Yeah. Okay. So last one, real quick. Let's just roll through it. What do I do to get my x-intercept? Cover up the y. What will I write down if I cover up the y? 2x equals 10. What do I then divide by? 2. I don't divide by 5. I divide by 2 to get what, Jaden? 5. How do I write that as a coordinate point? 5, comma 0. Okay. Y-intercept, what do I cover up? X. So what should I write down? Negative 5y equals 10. What do I divide by? What kind of 5? Negative 5. Be careful, negative 5. What is 10 divided by negative 5? Negative 2. Careful with your signs. How do we write this as a coordinate point? 0, comma, negative 2. Look at you guys go. You're so smart. Put a dot at 5, 0 on your x-axis. Put a dot at negative 2 on your y-axis. Make your line. All right, so tonight's homework. If you're online,